Okay, so following on from permutations, we're going to talk about combinations. And what is a combination? A combination is a selection where order does not matter. Okay, a combination is a selection where order does not matter. And let's do an example. Suppose we select 3 people from a group of 10. Okay, we select 3 people from a group of 10. How many are we going to end up with? Well, let's just go back a couple of pages here. We saw that the number of ways we could take 3 people from 10 in such a way that order mattered was 720. Okay? But now it doesn't matter what order those 3 people are chosen in. So what would we have? Well, then we would have the number then of ways would be equal to 10 permute 3, which is the total number of ways I can choose where the order matters, and then I just divide by the number of orders, divide by the number of possible orders of 3 people, okay, which is 3 factorial, okay. So what do I end up with here? We call this, by the way, we call this 10 choose 3, okay, or 10 combine 3, depending on what you want to see that as being expressed as, okay. So what's the number of possible ways? Well, I would have this one here, which was 10 factorial, and then I had 10 minus 3 factorial on the bottom, and now I'm going to divide that by 3 factorial, okay? So this gave me 10 factorial over 7 factorial, divided by 3 factorial, and then what I end up with is 10 factorial, and I have 7 factorial, and I have 3 factorial on the bottom, okay? And before we saw that this was equal to 720, and 3 factorial is 3 by 2 by 1, so that would be divided by 6, okay? So what do I have? Okay, I would have 10 factorial, okay, and then on the bottom I would have 7 factorial multiplied by 3 factorial, which is here, okay? And if I put that in, we'll see that we get an answer of 120. Okay, and 120 is of course 720 divided by 6. And this here gives me the general form, okay? So in general, okay, if we choose or objects, individuals from n, many, where order doesn't matter, what do we have? Sorry, this is sticking here a bit. Okay. Okay, then we have n choose or, okay, which is going to be, it's going to be n factorial on top, like the 10 factorial I had before. And then I'll have the n minus or factorial here. And I'll have the or factorial there, okay? So the example we had there was 10 choose 3. We had 10 factorial on top. We had 10 minus 3, which gave me the 7 factorial. And we have the 3 factorial here, okay? And you might see this written just with the opposite order on the bottom, which is the same thing, of course. You might see it as or factorial, then n minus or factorial, like that. Okay, it's the same thing, okay? And we'll do a couple of examples. Let's say I want to choose what do we have here? Let's choose 5 cards. From the deck. And the order does not matter. Okay, well then what would I have? I would have 52 cards in total. I would be choosing 5 of them, and that would be 52 factorial on top. I would have 5 factorial on the bottom, and I would have 52 minus 5 factorial. Okay, so what would that be? That would be 52 factorial. We would have 5 factorial, and 52 minus 5 is of course 47, so 47 factorial. Like that, okay? And can I give you the number? Well, yes I can, but I'm not going to do it this way, okay? And the reason I'm not going to do it that way is because, like I said before, 52 factorial is such a big number that my calculator will only give it to me in scientific notation. So what I'm going to do is I'm going to use a special function on my calculator which does this computation for me. Okay, and in fact this is not really all that difficult to do. I'll do it out long in a moment. But how do I get the actual answer? Okay, I go 52 and then I find the NCOR on my calculator. See that? NCOR, it's a second function. 52 choose 5. And that is 2598960. Okay. And of course, one way I could get this is that I could realize that 47 factorial actually cancels into the 52 factorial. So what do I have? I have 52 on top by 51 all the way down to by 3 by 2 by 1. Okay. I'm going to leave the 5 factorial here for a moment, okay, because it's reasonably small. And then I have 47 factorial, okay, which is 47 by what? By 46 all the way down to by 3 by 2 by 1. Okay, and we can see that this 47 down to 1 is going to cancel with the 47 down to 1 on top. So what do I actually end up with? Well, on top here, I'm just going to have 52 by 51 by 50 by 49 by 48. Okay, that'll be the only thing that appears on top because it will cancel with all of this. And now all I need to worry about is the 5 factorial, which is 5 by 4 by 3 by 2 by 1. And you can always find cancellations here, okay? So for example, I can see that 5 goes into 50 and leaves me with a 10, okay, which is fairly straightforward, okay. I know that 4 goes into 48, okay. 4 would go into 48 and leave me with a 12, okay. 3 would go into the 12 and leave me with a 4, okay, so that's a second cancellation. And I can put 2 into 52 and leave me with 26. Okay, so the numbers end up quite a bit smaller. And I would end up with 26 by 51 by 10 by 49 by 4. And that'll give me the same answer there. Okay, so you can go longhand, or you can do what I would recommend, which is just to use the combination function on your calculator. Okay. But people were able to make, serious attempts at this before calculators existed, and when you break the expressions down in this way and start reducing things to smaller numbers, it makes sense how to do so. Okay. One thing I want you to imagine here. Okay. Suppose we have a group of 10 people. Okay, and we must choose 4 people for some task. Okay. Well, then how many people would I have? I would have 10 choose 4, okay, which I can get on my calculator. 10 choose 4, and that's a total of 210. Okay. There are 210 ways that I can choose 4 people from 10 in such a way that order does not matter. Okay. Is the number of ways I can do that. Okay. However, if I choose 4 people from 10, okay, that means I'm also choosing 6 people to leave behind. Okay, so I can imagine this as choosing 4 people to be on my my group that will do the task, or I can imagine it as imagining 6 people that I have to leave behind. Okay, so what do we find? Well, 10 choose 6 then, if I put that into my calculator, 10 choose 6 is also 210. Okay, why is that? Okay, well, it's very, very simple. If I choose 4 people from 10, I am also choosing 6 people to leave behind. If I choose 6 people from 10, I am also choosing 4 people to leave behind. So there's always this, this relationship, okay? So in general, n choose or is always the same thing as n choose n minus 4, like that, okay? So for example, when I'm working with big numbers in my head, okay, say for example I wanted to find the number of ways that I could choose I don't know, a group of 50 people from a group of 65, the way I would think of that is that I'm really looking for the 15 people that I'm leaving behind, and it makes the numbers smaller. It makes things easier to visualize for me. So that's just something you can be aware of. That's a helpful little hint. Okay, and it's always true. Okay, that's not true for permutations, by the way. That's only true for combinations. Okay, for permutations, obviously, if I choose 6 people and permute them in some order, it's not the same as choosing 4 people and permuting them in some order. Okay. Okay, so it's only true for combinations. Okay. There's a formula for that here, and we'll talk about some examples in a future video. I just want to give you one more little connection about how this relates to probabilities. Okay. So suppose, for example, if all outcomes are equally likely. Okay. Then we can kind of have, we can talk about discuss probabilities. Remember, the probability of some event A was equal to the number of ways A occurs over the number of total possible outcomes and what is that? Okay, well, let's do an example here. Sorry, just had to pause there for a moment. Okay, let's do an example. Let's say we have a lottery. Let's say we have a lottery machine, okay? And say I want to know the number of ways that I can get a particular combination, okay? The number of ways that I can get the total number of combinations. Well, that depends obviously on the number of numbered balls in my lottery machine. Let's say that I have 20 numbered balls. Well then, and let's say that I have to draw, say 6 of them. Okay, well then I would have 20, choose 6, okay, and 20, choose 6 then would be 38760, which would be the number of possible ways that I could, the number of possible combinations of 6 balls from 20, and it's still about 40,000, which is quite large. And of course, the Irish lottery or Euro Millions have more balls than 20, and the number goes up very, very quickly. I'll just check here what the Irish lottery... Okay, so it says the Irish lottery has 47 balls. Okay, 47 balls. So 47, okay, choose 6, is quite large. Okay, that's about 10 million, 10.7 million. Okay. It's 47, choose 6, which is 10,737,573. That's the number of possibilities. Okay. So what is the likelihood that you win the lotto? Okay. Okay, assuming that you, suppose you have let's say 10 lines for the Irish lotto. Okay, well then your chance of winning What's your chance of winning? Well, you have 10 outcomes where you win over the total number of outcomes, which is 10,737,573, which, you know, is about 1 in a million if you buy 10 lines. Okay, and I'm ignoring the bonus ball. I'm ignoring the bonus ball. Okay. So we'll talk a bit more about how these relate to probabilities in some different examples. I'll do one real quick here. Let's say, for example, I want to know the number of possible ways that I can get a royal flush in poker. Okay, how many different ways can you get a royal flush? Well, I'll do it in hearts here because that's what I'm finding first. It's the Queen of Hearts. It's the King of Hearts. I also need the Jack of Hearts, which is here somewhere. There's the Jack of Hearts. So, if you do not play poker, a royal flush is a straight flush in the highest cards. So 10, Jack, Queen, King, Ace, all of the same suit. That is the only possibility. So how many of these are there? Well, there's 4. There's 1 in each suit. Okay. Spades, hearts, diamonds, clubs. Okay. So what are your chances of getting a royal flush if you select 5 cards at random from the deck? Okay. Royal flush if we draw 5 cards. Okay, what's the chance of getting a royal flush if we draw 5 cards? Well, if we draw 5 cards from 52, that's 52, choose 5, all right? Which is a number that we saw earlier. 52, choose 5. Okay, was 2598960. Okay, it's a big number. Okay, that looks like a 6 there. It's a 0. Okay, so the chance of getting a royal flush, that's the total possible number of draws. Okay, so the answer then would be that there are 4 possible royal flushes over this number 2598960. Okay, which is very small. 4 divided by my answer. Okay, that would be about 1 in a million, 1.5 in a million. Okay, 1 and 2. Another way of saying that is 3 in 2 million. Okay. Okay, and I used to play a lot of poker live, and I have never ever gotten a royal flush. Even in games like Texas Hold'em, Pot Limit Omaha, where the game structure is different and you actually have a much higher chance of getting a royal flush. I've never ever had one. Okay, so very unusual, almost like a lottery win. Okay, so we'll do some examples in the next videos. We'll look at some exam questions, and hopefully you'll be able to follow me through them. Okay, thanks everyone. Bye.